In this video, I'm going to solve this optimization problem. So we have a right circular cone. It's inscribed in a sphere of radius 1 meter. We want to find the maximum volume that the cone may have. Since this sphere has radius 1, we know that this distance from the outside of the sphere to the center is equal to 1 meter, and this distance is also 1 meter. So I've gone ahead and labeled those two lengths 1 meter. Now I'd like to maximize the volume of the cone, and I know that the volume of a cone is 1/3 pi r squared h, so I'm going to label the dimensions of the cone. So I've labeled the radius of the cone r, and I've labeled its height h. And I know that the volume of a cone is equal to 1/3 pi r squared h, and I want to maximize the volume. So now that I've figured out what I want to maximize, I need to get this in terms of one variable. So I need to get r in terms of h, or h in terms of r. But another thing I know about this picture is that since this length is h, and this length is 1, I know that this length here has to be h minus 1. And I know then that by the Pythagorean theorem, h minus 1 squared plus r squared has to equal 1 squared. So that's how I can write r in terms of h. In fact, I'd be better off just writing r squared in terms of h, and then I could just substitute it into this part of the formula for the volume. So I have h minus 1 squared plus r squared is 1 squared, or I can rewrite that as r squared equals 1 minus h minus 1 squared, and I will square that and simplify to get 2h minus h squared. So then the volume as a function of h is 1/3 pi r squared, which is 2h minus h squared, times h. So now I have this as a function of h, and if we think about this for a minute, we know that h lies in the closed interval 0 to 2. That's because the radius of the sphere is 1, so at most that height could be 2. And that, simplifying before I differentiate, is equal to pi over 3 times 2h squared minus h cubed. So now I'll differentiate. So v prime of h is pi over 3 times 4h minus 3h squared, which is pi over 3 times h times 4 minus 3h. And to get the critical numbers, I'd like to know when v prime h is 0, and that happens either when h is 0 or when h is equal to 4/3. And now I'm going to use the closed interval method to show that h equals 4/3 gives us a maximum for the function v of h. So recall that v of h is equal to pi over 3 times 2h minus h cubed, and h is in the closed interval 0, 2. So v of 0 is equal to 0, and v of 2 is equal to 0. And V of our critical number, 4/3, is equal to pi over 3 times 2 times 4/3 minus 4/3 cubed. And if I work that out, I get 32 pi over 81, which is certainly larger than V of 0 or V of 2. So I know by the closed interval method, the critical number, h equals 4/3, will give me a maximum. So by the closed interval method, height equal to 4/3 meters will give a maximum. And in the question, I was asked to actually maximize the volume. So I should say what the maximum volume is. The maximum volume is 32 pi over 81 cubic meters.